it's just a minute. Okay, let me see this thing. This thing. Yeah. Okay, so can you hear me? Hello, can you hear me?
Yes, I can hear you.
Okay, so have you tried my the click on this the new link that I just the in the chat? It should work. Did you click on that? Let me know if you it should work. If it's not working, then let me know. Okay. So not this one. What am I doing here? No, not this one.
Okay, that one worked.
That was good, 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 good,
Thank you.
good. All right, good. So this is just I just started making the new channels. So I mean my channel. So started a new channel. So the if you subscribe, that'll be appreciated. Okay. So this is a biostat. Okay.
I just did. I just subscribed.
Okay, good, good, good. You are the first one to subscribe. Anyway, so I'm gonna upload my the educational, mostly educational teaching material, the recordings in there. So what I do is like I think this is the kind of the scientific research. If you are just watching lectures, right? Watching only, that will probably about you get retain about 5% of your the material. Okay, watching and annotate, you annotate, you get about 15%, right? And then watching it again, then you will probably get the 25%, something like that. Okay, but if you teach the some the if you after, I mean, of course you have to know the material, so you after you watch it and then teach, then it will increase surprisingly 93%. You will understand that you will retain your knowledge about 93%. Huge increase in here, right? So the making it the reciting myself to like teach like record myself for the other materials that I understand, and recording it and put it to YouTube. That will make a really really big increase. That's for my own benefit as well, but I think you should do the same. You should, when you understand the material, right, try to record it. Or I mean, if you don't want to like hassle with the recording it, you can just recite by yourself in front of mirror, or even without mirror, it's fine. Try to teach yourself. So try to explain yourself instead of just keep watching. Doesn't really help. Even if you watch it like 2 times or maybe 3 times, 4 times, that will increase probably, be even 25% to maybe 40%, probably. I'm just guessing. Okay, but if you teach, that it has a big, huge increase. Okay, so highly recommend you you do this kind of practice. So basically try to teach yourself, and then if you whenever you are eligible to become a TA, you know you definitely I highly recommend to become a TA. Okay, so that will make you the retain your knowledge is huge, big time. Okay, all right. Like I said, this the session is very very unique because and not this session, but the his class. Dr. Akuna's, it's very likely that the Dr. Akuna will teach you guys, which and some people say is very unfortunate, or some people say very few people will say, oh, it's fortunate. Okay, so anyway, so what I'll do is that let me just go back to the very last page. This you might wanna screen capture, or I can why don't I do this? I can send the link for this one. The problem is, that has my annotations. You'll have a hard time to reading it. Let me see if I can do that. If I can do, let me see if I can do. Oh shoot, this thing again. Uh, I might have some link because I downloaded from somebody else. So I will send the link right now. Just a minute. Let me just log out here, and then the send you the book. Okay, I send you the link, and oh shoot. Just a minute. Okay, I'll send you the link that where I got it from. Okay, so the link was, I think, in here maybe. Let me see. What happened here? Okay, okay, so why don't I do this? Why don't I say, if I find the link, I will send it to you. Okay, so that's the book that he will use. Okay, and he recommended you read this book. And then what I did was like just the kind of caveat that I read it. But this is like 400 some pages, 407 pages. It's too long to read, through whole thing. So, and then the writing is not very, kind of on the very like easy reading. Some expressions are very hard, and I don't know what he was talking about. So I try to solve the questions for me, the practice questions in the back of each chapter. I think there are 14 chapters. So in each chapter has about 10 to 15 questions. And then I try to solve it. And then I get like out of 15, I get like maybe one right or two right. So I thought, oh my God, this must be wrong. This like maybe it's maybe looking at the wrong chapters or something like that. So don't get disappointed. It's the questions are very hard. Okay, in general. Okay, so but this is what he recommends, and of course, if you have time, you can read all of them, and that will make more better understanding, of course. But it takes very long time. So at least to do the practice question, and then don't get frustrated, even if you get like, oh my God, one out of the 15 right. Don't get disappointed. Okay. But so what I recommend is either you do the practice questions, because of course, if you do the second try, second attempt, like do the practice questions twice, then you will have a much better better, what is it, better the percentage of right. So either you do the practice questions twice or three times, or spend some time to read the explanations, and then you read the like chapters. Okay, so because it's you have to plan ahead of time, because it's a 400 pages book, so which is not very kind of easy to read. So, okay, so that's kind of recommendation to you. But if Dr. Akuna teaches you, okay, if somebody else teaches you, just understand, probably understand, just if you know this slide, you are probably okay. If somebody else teaches you, and then because of what happened is if you someone asked to the Dr. Akuna, someone in my class asked Dr. Akuna, here's the conversation. She asked, okay, what should I study? Should I study solve the U-word question? And then he said, what's the U-word? So that was the conversation. So what I mean is that he's teaching. He doesn't know anything about the step. Although he took the opportunity, he took the step long time ago. He doesn't know what's going to be the good source, good resource for the studying for step one. So you got to be careful about this. So you have to, basically, you have to. How can I say? You have to kind of the you have to kind of you know understand what he is teaching. So what you have to basically his teaching is his emphasis is not really a step one. So very it's kind of irony. So but if you just okay, I'm gonna study only step one. If your target is step one for like everyone else, so it's only you can completely disregard what he's teaching, but that's of course there's it's not also good. You will lose 10% of the whole grade, right? So I did like really I had like a kind of hard time in terms of what his class is. Okay. So, if you understand this the topics that I'm uh, in this slide, then you will be good at least for the prepare for the step one exam. Okay. So, all right. Research design. Research design basically have like two major the different branches of the research design. One is the observational, and then the other one is experimental. Experimental means that do you know the randomized control trial, right? Like the drug studies. So when they develop a new drug, they do kind of the randomized control trial, meaning that they recruit a lot of people to take the drug, and whether that has a toxicity or that has any effect or any the it's better than previous drugs. So you first in phase 1, 2, 3, 4. In phase 1, you basically focus on the toxicity, whether it's toxic. And second, so this one is like for healthy people, phase 1. And then second, you test for the efficacy. Is it effective? So small number of the patients. Okay. And then in the third, you compare with the previous drug or current drug. So compare, and then the efficacy, and then lastly, phase 4, you this is like you get FDA approval, and uh, it's already in the market, and then you find out you still do the randomized control trial because by investigating the people who already they use that drug for a long time, so long-term effect. Okay, so toxicity, efficacy, comparison, the marketing or long-term. Okay, so those are the phases of the experimental design. Okay, so experimental design and then observational style. Observational design is basically I'm gonna explain this to you, but observational is basically there are different types of the studies in here. Okay, there are descriptive studies. and then longitudinal studies. Descriptive studies is something like you kind of interview people. So if there's some other the new case coming in, new say the COVID case came in at the very beginning, right? You remember 2019, the winter, new cases came in, and then they are trying to interview people, and they are trying to investigate that particular person. That okay, so the what's going on, what where were you, and then what did you eat, what the who did you contact, and that kind of stuff, and then what's the symptoms like, that kind of stuff. So okay, basically it's not really investigating like group of people and the do some kind of statistical analysis. It's more like a kind of descriptive. So no, nothing to compare. You just basically try to find out what was the cause by interviewing them, by investigating them. Okay, so that's if it's one person, then the case report. If it's many people, then it's a case series. But key point is here is that no comparison, no comparison. So in other studies, you compare with whether this new drug is effective, or whether the if you are suspecting, say, lead poisoning, if the lead poisoning has some effect, right? Lead poisoning causes some other mental defect, or if you can, so you compare that whether the lead poisoning people or non-lead poisoning people by investigating, do you live in old houses, or do you have some kind of the near the lead mine or something like that, right? But or maybe the you use do you know fishing when you go to fishing, right? You use the kind of lead, the weight, small lead weight, so that will make the fishing pole to sink, so that the fish can bite the bait. So that is made of lead. Okay, so that kind of stuff, or the what is it that the I think the brake, the car brake also has some kind of lead or something like that. So that kind of things. So what's the like maybe a suspected cause? So that's kind of the case report, but they do not compare with the other things. Okay, non-exposure, exposure, non-exposure, they don't compare. Or lung cancer, no lung cancer, they don't compare. Okay, so that's what the case report is, just a descriptive. And then cross-sectional studies is the you study the certain time. So basically, the key point here is same time, same time. And for instance, same time means like December 8th, 2023, we just go to hospital, and then we look at the chart. We look at the chart. Oh, this guy had the lung cancer right now. Okay, did he have any smoking history? So we don't really go back to the time and then to find out whether he was a smoker or non-smoker in say since 2012 and until now, 10 years ago and then till now. We don't really compare them. We just look at their chart. Was it he's a smoker or non-smoker? So we look at the same time means that the effect, I mean the exposure, sorry, exposure, and then the outcome. I will use E, and then I will use O for this for simplicity. Okay, exposure, outcome at the same time. Look at the of course it doesn't occur at the same time, but we are looking at that things, those two things, exposure and then the outcome at the same time on the December 8th, 2023. So we look at their chart, and then this guy is a smoker or non-smoker, or this guy has the lung cancer or no lung cancer. Okay, so same time is a keyword. Exposure, same time means the exposure and the outcome at the same time. Okay, ecological study is basically population. keyword here is population instead of sampling. Okay. Obviously, population study will be the best, but of course, it costs more money, and then also, it's there's a consent pros, right? So, so that's the things. That's the kind of the descriptive study. This is all descriptive study, because descriptive study simply means that there's no comparison. Or yeah, and then other. Oh yeah, one thing I forgot mention here. Key point here: cross-sectional. You find out prevalence. Prevalence. Okay, prevalence. Cross-sectional, the measure that are the statistical measure that you will find out is a cross-section. I mean the prevalence. Okay, cross-sectional prevalence. Okay. All right. Now there's also longitudinal studies, which is like more popular the studies. So you will learn. So there's like a cohort study and then case control study. Okay, cohort means that actually don't get confused with the cohort. Cohort is an English word. It's a group of people. Okay, cohort means just English word. The cohort is the English word that simply means the group of people. Don't get confused with the cohort study. Okay, this is just it's not cohort study. Okay, this is nothing to do with the cohort study. Okay, but the surprisingly they use when they express the group of people in the question, many of the vignette in the question, they will use the word cohort to confuse you. Don't get tricked on that. Okay, it's really bothering me. They use a cohort wording intentionally just to confuse you. Okay, so don't get tripped on that. Only it's just is whether it's the cohort study or it's different, totally different thing. It's nothing to do with the cohort, the meaning. Okay, so exposure outcome, right? What you in cohort study means that you are collecting the people, you recruit the people based on the exposure. So, oh, did you smoke? Or did you not smoke 10 years ago? And go back to the time, instead of right now, it's go back to the time in, say, 2020, year 2000. And then you look at the chart. Did you, or interview people, did you smoke from the 2000 year 2000, or did you not smoke? Okay, exposure or no exposure, exposure or no exposure. That's the core study. Okay, whereas case control is, oh, actually, sorry, one more thing. Core study, if we go back year 2000 and did you smoke in 2000 or did you not smoke from 2000? That's a retrospective. We are going backward to time, right? So that's called retrospective core study. But more understandable type of core study is a prospective. So so you ask the divide the two groups. One is say because smoking and non-smoking is not really a good measure because that might harm you the patient, right? So maybe something else. Say you have some BRCA mutation, BRCA or no BRCA right now, and then does it cause a breast cancer in 10 years? Okay, so that kind of things. So just for simplicity, smoking or no smoking, smoking or no smoking now, and then go back. I mean not to go back. Like follow them for 10 years. Year 2033, 10 years from now, you see if this guy has the lung cancer or no lung cancer. Okay, so exposure, no exposure is a key. That's a core study. And then you follow them through 10 years, and then you see if they develop lung cancer or no lung cancer. Okay, so it can be retrospective or prospective. Okay, prospective is more common, but it obviously this will be like very time consuming. Okay, and then expensive too, right? Because we have to follow 10 years. Okay, another type of study is very useful is the case control study. Case control study is the symptoms or outcomes. You are focusing on the outcomes only. So you divide the group by lung cancer or the no lung cancer group. So you go to patient, you go to hospital, and then okay, this guy has a lung cancer. Okay, lung cancer group, and then no lung cancer group, and then we like investigate whether this guy had the smoking history. Okay, so focus is in here. Lung cancer or no lung cancer. Okay, no lung cancer or no lung cancer. And then did you smoke? Did you not smoke? No lung cancer. Did you smoke or did you not smoke? Then whereas this cohort study, you had the smoking history, no smoking history. And then in 10 years, did you have do you have the lung cancer or no lung cancer? No lung cancer, no smoking. Okay, did you develop the lung cancer or did you not develop the lung cancer? Okay, so that's the difference. So understanding this is very important because of the reason this is important is that their question will ask this. Okay, question will be asking, when you measure something, some statistics, they will say this, there's some numbers here, right? Numbers, two by two table have numbers. What does this, the number represent? Okay, so you have to understand, what these numbers, probability or numbers, represent. So basically, the difficult part in the biostatistics, all about the interpretation. Okay, interpreting the English word is very, very important. Okay. So another thing is that in cohort study, let me use a different pencil. In cohort study, all all statistical measure possible. But in case control study, only odd ratio, odd ratio, odd ratio only. So there are other things you can measure, but because it's no matter what study it is, you will build up two by two table. Okay, but even if you have a number, so you can measure according to the formula. You can measure the like relative ratio, odd ratio, likelihood ratio, and all other things. Doesn't matter. That has no meaning other than odd ratio. Okay, that's the thing you need to know. Okay, so and for the if it's a case control in cohort study, everything is meaningful except the odd ratio. Okay, all meaningful, all stat possible and meaningful, but except odd ratio, only odd ratio. All right, there's something you need to know. And then there's like a randomized control trial. This thing is basically the clinical trials. Okay, so clinical trials can be it has to be the randomized. If it's not randomized, it's a lot of bias, right? So if it has to be controlled. Controlled meaning that the control simply means that the follow the rule. Okay, and then blinded, it can be double blinded, triple blinded. Mostly, the double blinded is usually the most common cases. So triple blinded simply means that the data analysis also be blinded. Okay, you don't know what samples are you investigating. Okay, so also another study is crossover studies. Say you have a drug A and the drug B, drug A group, drug B group. Now, after some time, like you stop taking drug A, drug B, and then now there's during some washout period, you don't just give them anything. And then crossover. Now drug A group takes the drug B. Drug B group now taking A. Okay, that's a crossover study. Okay, and then the drug trial phase is, I explained it to you, right? And then also errors, statistic equals error, measuring error. What kind of error it is? That's all about the statistic. And personally, my undergraduate major was statistics. And when I was in Stanford, I first focused on the statistic part when I did masters. Okay, so I'm very familiar with it. I mean, not. I would say like I'm not very familiar, but I studied a lot of time in statistics. That doesn't mean that I remember everything, but it's but what the so biostat part I'm okay, but in epi part is like a very different. Okay, so epi part is the what Dr. Akuna is focusing on. Okay, but what I'm in this whole slide is mostly biostat part. Okay, that's what I can say. And now there's like errors. Okay, there are two types of kind of errors, but it's a precision, and then you need to understand the accuracy and precision. Accuracy simply means that a lot of points that a lot of can I say okay, a lot of points that will be yeah, that will be near. I mean that will be centered toward the target. So this can be. Let me just this way. This can be, oh, yeah, this can be, everything here is perfect, right? There's I shoot it, and then everything is just around here. That's perfectly accurate and perfectly precise, right? But then oh, yeah, why don't I just like this? That's a perfectly precise and then accurate. Low accuracy, but high precision simply means the target, the is I mean target is here, but you the how do you call that? You should like near like far away from the target, but your like the bullet points are clustered together. That's the high precision, low accuracy. Low precision, high accuracy means that you go here, here, all the way, all over, but if we are just basically from this center, kind of to all the bullet point centered at the target point, but it's not close together. This is called low precision, high accuracy. Okay. Low precision, high accuracy, it'd be like this. It's not close to it's not centered to the target, but it's just somewhere else. But then also it's not clustered together. Okay. All right. So that's what that is. And also important thing here is random error, systemic error. Random error, another word, random error is probabilistic error, and then it's the same as the allowable error. Then non systemic error. Sometimes I call it good error. Okay, and so what that means is that this is like a true, sometimes called true error. Okay, all same thing. Okay, and then systemic error need to be corrected. Bad error. So non-probabilistic error. All same thing. Okay, so you need to know this kind of terms. Okay, if you want, you can screen capture this because it will disappear. All right. All right. So next topic is going to be the recurrent bias. So this is what the bias simply means systemic errors. So there are many different types of biases. That maybe about 20, some more than 20 different types of biases. That this is a thing that we will have to find out, and we will have to remove these errors. Okay, so basically the main one of the like major area in biostatistics is how to get rid of this error. Okay, so there are different types of errors, and then there's basically sampling error. If you like, if you find the samples, this is a whole population. Samples has to be like this many. You cannot like, you say like 2 million people. You don't want to investigate 2 million people. That's too many, right? So if you want to find out the good samples and then small bad sample simply means that if you have the 2 million people is a population, then this small sample is it really representing? Okay, this has for instance this or like say for instance like 80% of people are the sickle cell anemia. Okay, now you and then the sampled only white people. The sickle cell area is more popular in like the black people, right? Black population. So if you happen to be if you go to like Colorado or Wyoming, Wyoming, right? If you go to Wyoming and sample try to do some study, in Wyoming has a very high the white population, whereas sickle cell anemia is very black people population, right? So if you sample many people from the Wyoming, doesn't really represent, because you will be erroneously conclude that, oh yeah, the sickle cell anemia is not a big concern. But that's a big concern for black population. So if you go to like if you wanna study for the sickle cell anemia, you have to sample them correctly. So say the 80% of population has a sickle cell anemia, you have to select a sample that has also 80% population black, and then 20% population non-black. That's how you're supposed to sample it, right? So the sample has to basically have a very similar characteristic as the population. Okay, that's the key. All right. Now, performing bias is that when during the study. By the way, this the biostat is a kind of almost like it very looks like a very the unrelated to the scientific, but you have to know this. Science simply means evidence-based medicine, right? Scientific research is basically evidence-based medicine. So what does evidence-based mean? You can be like what we understand as a science. So for instance, some like gene, the like BRCA mutation has this mutation causes the breast cancer. So BRCA mutation, you can recover it. There's some kind of chemical change, biochemical changes, and because of this, the mutation in the gene, it will cause the breast cancer. So that's really the really kind of lab type of the science, right? That's what we very familiar with in other subjects, right? In other systems, we always like okay, hypertension causing like the atherosclerosis causing like the MI and that kind of stuff, right? So we can explain the thing, right? But there are many other things. Do you know that like only we can explain the things like only maybe about less than 20% of the whole disease. If we can explain whole thing, all kind of every disease, if we cannot explain, we don't need to study medicine. Everything is already there. So less than 20% is what we know. The reason that we learn something, some study, some disease, and then the only maybe we learn diseases and we claim that only like maybe 10% is idiopathic, right? The reason that the we the diseases that we know we are learning, and then only 10% is idiopathic is because we don't because the disease is whole set here, and then we only learn this much disease only. This actually there are many more diseases that we don't know the cause. That those kind of disease we don't simplify. We cannot just we don't care, or we don't know what the cause is. He died of some disease, and we don't simply know. So we just don't study that those kind of disease, or even if we know something, we just like for instance the sudden infant death, right? See, we don't know the exact cause. We just guess few causes. We don't know how he died, right? So this kind of things, that's why we call it idiopathic. But idiopathic is because of what we are only focusing on this much of the disease out of whole disease. So out of whole disease is still needs a lot of research in terms of statistics. So statistically, we do think, the all kind of this study, and then if that proves that okay, there are highly related, lung cancer. I mean the smoking to the lung cancer. We conclude that there's a significant relationship between the smoking and the lung cancer. That's how we conclude it. Okay, so that's all the evidence-based medicine. So it's not only the lab oriented, it also statistics, also is the part of the big part of the lab, evidence-based medicine, which is about like 80% of the whole thing. Whole disease is statistically proven the the disease, and then this only 20% is like the have a solid proof that if we have this mutation, you will have the kind of the disease. Okay, so that's why this the statistic the part is biostatistics part is very important, and then the percentages of the biostatistic questions in the exam will be much higher than 10 years before. So it's getting increasing. So whenever you see the biostatistics, ethics questions, or the something like the old people, geriatric, or young people, or the pediatric, or pregnant people, the obgyn questions, you have to be it will be increasing percentages. Okay, all right. Now, okay, where are we? so, bias is important, and then performing bias means that the recall bias. So, patient don't know what happens. What did you eat? Like the yesterday. That's easy to remember. But what did you eat 10 years ago? You cannot remember. Nobody remembers, right? So that's something that you need to consider when you ask a question. So I'm trying to get in. Um, how can how can like how can anybody let the Jonathan in? Mm, um, okay, if you can let Jonathan in, just let me know. And I think so. There's a some kind of let me see. How can I add in Jonathan? What's his name? Oh, this his last name is Sunshine, okay. Sunshine. Sunshine Jonathan, right. You request to join. Okay. So
Thank you.
okay. Yeah. Okay, no problem. So there's the recall bias. That's the recall bias. So the patient cannot recall. Okay, and another the bias is measurement bias. Measurement bias is like, for instance, you have a wrong scale. So you're measuring the body mass, the like BMI, and then you are using the wrong scale. That's one kind of the measurement bias. And then there's another thing. One thing you need to know is the Hodon effect. Hodon effect is, for instance, um, okay, so now we are doing the study, and then for hand washing causing some kind of disease. So, so I announced the people that okay, so we to the sample or to the maybe hospital step that okay, I'm gonna install the CCTV just in front of you, the washing basin that the we are trying to study for the hand washing and the relationship between hand washing and then causing infectious diseases. Then everybody will wash it, right? So they don't have to be wash it. Oh my God! Then they if I don't wash, then they will just pick me in, and then probably maybe the fire me or something like that, right? So that's you are being washed. So that's called the Hawthorne effect. Okay. Also, another thing is that procedure virus. There's some kind of, this is a kind of, when, especially one kind of new technique comes out, new surgery technique comes out. So, you wanna test the new surgery technique, whether that is more effective. So you are, but this is kind of, the very hard to avoid, right? Because of what happens is a new techniques, and then how can you compare with the like old techniques? So it is like if so you randomly do the old technique and then you randomly do the new technique. That's kind of inhumane. So that's unethical. So procedure bias either can be the ethical or unethical. So ethical issues. So you know the surgeons may be just like a kind of geared toward the bias to the like making intentional bias. Okay, so toward the like new techniques. Okay. Then observer bias is also also another name for that is like Pygmalion bias, Pygmalion effect. So meaning that, for instance, if you are if you're a surgeon and I mean if you are the doctor to you develop kind of new drugs. So your drugs you are basically your company developed a new drug. Your company tend to the show off that okay my drug works better, right? So that's kind of the that's called like the you have a high expectation. So oh yeah, this drug works really good, right? So that's the Pygmalion effect. Okay, all right. Also, there's like interpretation bias. Interpretation bias means that the lead time bias and then length time bias. So this difference is that if you have the lead time bias means that if you have, for instance, very specific the tool like diagnostic tool that you can only detect the cervical cancer. If you detect the cervical cancer earlier, then uh, what does it mean? You will, because you detect early, instead, normally, if you before this technique occurs, then cervical cancer was detected in here, and then cervical cancer was the initial the cervical cancer was occurring here, and then no, the before all the time, cervical cancer was detected in here, and then you die here, right? Now, new technique comes in. And then, so instead of the diagnosis here, you diagnosis early, like here, diagnosis early. So then you will eventually die. But, so the diagnosis early, because of this, you will have a longer time to survive. Because, you will do some kind of like, treatment here, right? So that will lengthen your life, right? Then you die eventually. But so this guy, I mean this girl, this girl has a cervical cancer here. Another girl also like was supposed to be diagnosed here. Then now diagnosed early, and then another girl here. So another girl here. She was supposed to be diagnosed maybe here, but then she was the diagnosed early in the stage like this. So her the life expectancy is longer. Now, does it mean that she has a more, I mean, there's a more cases? No, not really, because of the because here, if you look at this timeline here, diagnosis or normally you diagnose here, now you diagnosis here early, so you have a more diagnoses, more cases, more number of cases, right? So that means the prevalence is a increase, right? Prevalence increases. How about incidence? Incidence is a number of new cases. New cases increase too, right? So what is it? Is this like a kind of so we have a increased number of the incidence, increased number of prevalence. So is it the correct statement? So we developed like pap smear, and then after the pap smear, then we have a number of incidence increase and the number of prevalence increase. Is that the correct statement? No, not really, because we are doing something good, right? We simply diagnose earlier. That's why we have new cases, because if it would have been in the old, before the pap smear, it would have been detected much less later date. But now we detect early, and then people live longer. But we are the result in terms of statistics is that you after the pap smear, then we have more cases. It's not really true, right? So we just detect the people who wouldn't have been diagnosed as the cervical cancer. We detected early, right? We detected early. That's why he was categorized. She was categorized as the cervical cancer. But it's not because of the something wrong with the pap smear, right? So that's error, right? That's a bias. That's called lead time bias. Okay, and then length time bias is something like some kind of disease that is like the rapidly the progressing disease, rapid cancer, or as versus to the slow developing cancer. Slow developing cancer will have a higher the rate of cases, right? So doesn't mean that slow developing cancer is more safe or something like that, right? So that's the kind of length time bias. Okay. All right. So what I want to do is want you to know is that what does this mean? Okay. What does this mean? Don't try to memorize. Oh, lead time bias program. The previous. The prevalence low. I mean the incidence high. Don't try to memorize this. Try to understand what this means. What this means. Okay. One very important thing, which I intentionally didn't say, was a confounding bias. This, if any of the biostatistic questions you see in the USMLE or even in the Dr. Akuna's exam, okay, if confounding bias is not there, then I will call him. Okay, it has to be there. Very important thing, very common. And then also even in clinical practice, the confounding biases always occurring. Okay, so how to get rid of this thing is also important. Okay, let me use the good example. Let me see. Let me use the real pen. So, for instance, the like head size. Head size. Let me use a shoe size instead. Let's see. Okay, shoe size and the like IQ level. So we assumption is that usually the IQ level when very young age, right? In the not we are not talking about older people. We are talking about the kids. Okay, kids. Normally the IQ level is like goes like this, age here, and then goes like this. So in young age, basically newborn has a you can kind of assume that newborn has a 0 IQ. Okay, uh, and then his IQ will become the higher and higher, and then stops some age. Okay, so it's because of the brain is still developing. Okay, so you cannot measure the IQ very young age. Of course, it's like it's newborn. If it's say like a 3 months old baby having an IQ 220, that's not possible. Okay. Okay, that's not possible. And then the main reason is that you cannot measure effectively the exact IQ, accurate IQ when they are too young. Okay, so that's why the IQ is kind of increasing at certain age, like maybe I don't know, maybe 20, 18 or something like that. Okay, then it will stop. That's your real IQ. Okay, so we are talking about only in this period. Okay, so now okay, shoe size. There's a like the study that shoe size has a high IQ. So is this true? Is that's the like we studied the one of the studies says that big shoe size has a high IQ, and then there's a like maybe what's this? Why is the shoe size big shoe size big foot has the high IQ? It's kind of strange, right? Now there's a the age. Okay, then what about the age? Does shoe size have something to do with age? Yes. Shoe size has something to do with IQ? Yes. Both has a relationship, right? Listen carefully. Listen this relationship very carefully. Both has relationship, association, right? Association, association. Okay. Now, so why is it causing this? Now we re-examine these cases, and then what we found out is that maybe age is a confounding variable. Confounding variable. So what that means is that together, then founding is kind of it's really causing problem. Okay, and that has both the relationship associated in both the exposure and then outcome. Both the relationship, both associated, both. Okay, both exposure and outcome. Okay, now then how do you know is that okay? The age, young people and then old people, and then you look at the shoe size. So shoe size and then IQ. So young people in our case is like say like the 2 to 3 year old, okay? And then old in this case say the 18 I mean yeah 2 to 3 year old and then 18-year-old. Okay, So we divide into like two groups, okay? And then we do this, the shoe size IQ, shoe size IQ. What do you think this the relationship? Basically, no relationship, no relationship. Because what happens is, young people, they're like 2 to 3 years old, they have about, same size of shoe size, right? So shoe size here, and then IQ here. Same size shoe size, like shoe size will be just, it's not like a really, the huge difference. It will be just, shoe size will be about same, right? So it will be just, if you just plot it, it will be just like this, random plot. So there is you cannot conclude there's a relationship between shoe size and IQ. So in terms of the statistical measure, you will see, what you will see is a relative, oh, shoot, uh, relative ratio is going to be close to one, close to one. And if you calculate the relative ratio for shoe size and IQ for old people, relative ratio will be 1, 2. Okay. Here, relative ratio was say 2.1 to like 1, basically high, very good. Okay, high, and then meaning that this one meaning that no relationship, relationship. Okay. So this is very important. Okay, so I'll just highlight the key point here. You have to understand this thing very inside out. Okay, so shoe size, IQ, without even considering this, the age relationship is a very high IQ. I mean, very high relative risk. Okay, very high. Now then, you confound you find out confounding variable, which is the age. Then now you divide into young group and then old people, right? And then you do the shoe size, their shoe size, which will be about same, and then the IQ relationship. There's no relationship, no relationship. Then if this is happening, then age is a confounding variable or confounder. Okay, understanding this, yeah, try to understand this, the relationship here. This will give you minimum one questions. I mean, probably more than that. Probably minimum like 2 to 3 questions in USMLE 1. Okay, very important. Okay, right. And so next topic is like prevalence and instance. Prevalence is basically at certain point in time. Certain point in time, like point prevalence. So certain point in there's like an instance here. I mean, there's a disease the occurring here and then lasting here. He can die or he can recover, fully recover, and here or like this. Okay, and the prevalence means that point in time, but can be the period or like period of the prevalence. Okay, so let's just first talk about the point prevalence. Point prevalence simply means that certain point in time, like certain point in time, how many people have the disease at this time, and then this guy here, this guy here, like this, and then some people never have the disease, right? So how many people are all together in question? 1, 2, 3, 4, 5, 6, 7, say, the 8, 9, and the 10, 11 people. Out of 11 people, how many people have the disease at this time? Which is like the 1, 2, 3 people only, right? So 3 out of 11 is the prevalence of the point prevalence. of this time. How about the period prevalence? Period prevalence is like, say this was like January 1st, and then January, say 31st here. Then during the month of January 31st, during the month of January, how many people have the digit? There's one guy here, one guy here. This guy is also having a digit because it was here, right here. How about say this guy was right here? Yes, he has a digit too, right? Because it's within the period, right? So this guy has a digit, this guy not. This guy has digit, and no one has, right? So 1, 2, 3, 4, 5, 6, 7, 7. 7 out of 11 is the prevalence. Periodic prevalence in January. Okay, so that's you basically that's you the calculate the prevalence, and incidence is like a new cases. So if you have like this, and then the incidence always is has to have some kind of the duration. It has, if you instance cannot be without duration. It has to have a duration. It doesn't make sense because instance on time like point in time doesn't make sense at all. Because how can you say how many people have a new cases at say 2:08 p.m. Friday, December 8th? Nobody. Unless you are very, very lucky, or unlucky, that you just the new cases, you just get an age HIV right there. It's not possible, right? So you can, it doesn't have any meaning to it. So instance always have to have the timeline. So here to here, who has the how many new cases? So here, 1, 2 new cases. Those are 2 new cases during this period. Okay, so out of 1, 2, 3, 4, 5, 6. So 6 out of 6, 2 is the instance in month of January. Okay. Now, another important, very important point is that incidence, the prevalence is out of total say sample at risk. Okay, at risk is important. So, for instance, if you are looking at the number of prevalence for cervical cancer, we should not count for the males because male don't have cervix, so we cannot have the cervical cancer. Or people who got hysterectomy, so they don't have cervix, they cannot have cervical cancer. You have to get rid of it, right? You have to remove those people in the denominator. So total minus men, and then total minus hysterectomy people. Those people cannot have the cervical cancer. So people at risk has to be total people at risk is going to be the denominator. Okay. And then the incidence, and then the relationship between the prevalence and incidence is you have to know this one, right? In the long run, prevalence equal incidence times duration. This is on our case, and I saw these questions in the New World. I saw the same questions in the step 1. So this will be on the exam. I can guarantee if he forgot this question, this is so simple, right? This is a so simple question. If he forgets the confounding, and then if he forgets the P equal ID, that's something that he might have like the mental problem. or something that he will be making this question This is a very, very easy question. Of course, you cannot, of course, he will not say that, okay, what's the prevalence equals incidence times what? Nobody makes this kind of question. But of course, there's like some kind of clinical vignette. But, basically, the question is asking this thing, okay? So you have to know this, okay? All right. Another thing is that you in the cohort study, we discuss cohort, right? In cohort study, you will calculate the incidence, okay? And then prevalence, cross-sectional study, cross-sectional prevalence, cohort, instance, okay? Something you need to know. All right. Now, so far it's kind of more kind of the description, right? Now it's basically the milk of the biostatistic, milky part, meaning that that this is a kind of calculation part. Okay, so this calculation part, but memorizing the formula in the first state, for instance, first state. Let me just go to first state and show you what that means. About here, biostatistics, bio. Biostatistics, so about where's biostatistics? Oh, biostat. Oh, it's a public health part, I think. Yeah, here, right here. Okay. Understand, like memorizing this thing here, right? There's a relative risk and then attributable risk and all these kind of things, right? All these kind of things. Calculating this. Of course, you have to know this, but they will not make you this only, but just by knowing just by memorizing the formula and solve the questions. That will be probably maybe one or two questions, but that's kind of low yield. Okay, low yield, not high yield. Okay, one or maximum like one or two questions. Most of time they will ask, what does that number represent? Okay, so that's something you need to know, not just the formula. Okay, you have to go one step further uh, of the formula, not just memorizing. They don't like to memorize anything because what happens is ChatGPT, right? ChatGPT passed the USMLE, right? So they just passed, but last year. But if I'm sure that they evolved already, and then if they take it again now, they will probably ace the USMLE. They will probably you cannot human cannot beat that record because they know everything basically. So why would you spending a lot of money, a lot of time to become a doctor? We don't need a doctor anymore because a doctor, if doctor is basically data bank, they don't need that kind of doctor. Doctor now has to think. Doctor now has to be different from ChatGPT. Okay, doctor now have to interpret the things rather than, okay, so what's the relative risk? And then put the answer, you just enter this like 4 values here, and then 2 by 2 tables, and then what's the relative risk? They don't ask this kind of question. They know that this is not useful at all because ChatGPT do much faster, much the better job than than you. Just if you memorize it. So that's why I this is not really recommended, but I stopped using Anki when I was in Med 2. I stopped using Anki because this is not the way to memorization. The medicine is going toward the understanding and then interpreting rather than memorizing. Okay, so I don't mind you. I cannot. I cannot like recommend not to use the Anki. If you use Anki to help you understanding, that's good. But if you are using Anki to memorize things, I don't recommend that much. Okay. because it's not going to be the main thing that you will have to learn. You will have to learn how to understand it, how to interpret it. Okay, so likewise in here, it's a big thing that you have to the interpreting this. Okay, so what does the relative risk mean? What's the risk? How do you define risk? Risk is that some like out of some some like you have some disease, right? Chance, probability of a chance of having a disease. That's a basically risk, right? So in our study, we are in cohort study, we are basically all of this, like I said, all statistical measure is based on cohort, except the odd ratio, which is only in case control. Okay, so we are talking about unless otherwise, like I explicitly the odd ratio, everything will be a cohort study. Okay, so in cohort study, we are dividing the two groups: exposure group, non-exposure group, right? So relative risk means that we relatively risk 1 to risk 2, right? So it's something relative, means that we compare, right? So risk 1 and risk 2, right? So what do we compare? So we compare risk of exposure people and then risk of non-exposure people. Risk of exposure people and risk of the non-exposure people. Okay, so that's the relative risk. So what do you mean by risk of exposure people? Risk of exposure people is that number of people exposure over number of people disease. So the lung cancer, I mean the smoking people over lung cancer. That's the risk of exposure people. So out of people who smoke, how many people got lung cancer? That's the risk of exposure for the smoking people. How about the risk of how about the bottom part? Risk of non-exposure. So number of people who not smoke, number of people not smoke over number of people who smoke. I mean who lung cancer. Okay, that's the bottom part. Okay, so to compare this with the risk of the lung cancer with over risk of smoking. Okay, this is the relative risk. So in order to do that, what's this number? Say this was A, B, C, D. Okay, A is a true positive because if you the exposed positive and then the outcome positive, that's a true positive, and that this is a false positive. If we have a positive, but it is actually truth is the negative, so it's a false positive. So this is a false negative, true negative. Okay. So now what's this all these numbers risk of the not among the people not exposed, which is disposed, right? So not exposed, and then who has the lung cancer? So the lung cancer people is like basically this is the lung cancer people, right? So C out of C plus D, right? So in other words, false negative over false negative plus true positive, right? True negative, right? So C of C plus D is the bottom part. Now top part is who has the lung cancer, and then out of who exposed, who smoked. So in other words, that's the smoke is this part, right? So that's the true positive plus false positive, right? and then the who really has the lung cancer is a true positive, right? So in other words, this is A over A plus B over C plus D in short, right? So that's how you understand this, memorize this formula. You have to memorize this formula, yes, but that's not enough. You have to understand the formula. What understanding is this thing. You have to understand this thing to derive this formula. Okay, so don't try to memorize it at all. Don't try to understand it. Whenever you see the formula, you have to understand it. UV over P, right? Plasma concentration, urinary flow, and urine flow, and then urine concentration. You have to understand this. Don't try to, C equals UV over P. So what? They don't ask you to calculate this number. That will be probably maybe one out of, there's like, how many questions? There are four, so 282 questions, right, in the step one. They will probably ask maybe one or two questions maximum to use the formula. By just memorizing the formula, you will answer questions. That's only maybe one or two questions, no more than that. So they will ask you to understand the formula and then interpret the formula, okay? So that's the relative risk. And then basically, if the relative risk is 1, what does that mean? No matter you smoke, non-smoke, or smoke, it's same. Basically, that has it doesn't increase the chance of getting the lung cancer. Smoking or no smoking doesn't matter. You will have a lung cancer, same the equal probability. Okay, good example is instead of lung cancer, he say this is wearing red pants, and then no red pants. Obviously, obviously it doesn't have any relationship. So if you calculate this, then you will have the relative risk is equal to 1. Okay, in back to our the confounding the variable example, young age people, the big head, I mean the what is it, the head size, I mean the shoe size, right? Shoe size, and then IQ. So you calculate the shoe size and IQ, meaning that in this case, the shoe size is the exposure, and the IQ is the outcome, right? So then, in this case, you will divide into shoe size. Say, in this case, is there kind of shoe size not like it's not like a categorical variable. But if we the divide into groups, say for instance like this was like a group, right? Then if we just divide, say for instance the age 2 to 3 age group, they have like a shoe size range from say I don't know the size, but size 6 through 8. Okay, they are about same, right? So say size 6 to less than 7, say more than 7. Okay, less than 7, more than 7, but some young people have the size 8, but old people size 6. So suppose this was like almost like no difference in terms of age, right? Then this the less than size 7, more than the greater than size 7, and then IQ, for instance, like say maybe the 2 to 3 years old, maybe I don't know, maybe 60. Say it varies from 60 to 70. Okay, 65. Less than 65, more than 65. Probably, if you calculate this in the relative risk will be close to 1. Okay, this is how you calculate the relative risk. So confounding variable, relative risk. If you compound those, separate the confounders, then the relative risk for each compounders group will be 1. Okay. So the process that you do the confounding variable, that's as I explained, is called matching. Matching. Okay. So by doing matching, because I match it with the age group, young age, old age, right? So by doing the matching, you will remove the confounding bias. All right. This is very, very important topic. Okay. So that's why I go back to the confounding variable example. Okay. Another thing is the odd ratio. So odd ratio only for the control, case control. Okay. Case control odd ratio. You can calculate, because it's everything boil down to 2x2 table. You can calculate all variables, like in the as you see in the first stage. You can calculate the relative risk or everything here doesn't have any meaning to it. Okay, only meaningful measure in case control is a 2x2 table. Out of these all measures, you only meaningful measure is the odd ratio. Okay. So let me explain what the difference between odd ratio and then probability. If you are rolling a dice, what's the probability of getting 1 in dice? Okay, can anybody tell what's the probability of getting 1? Because I'm just keep talking only by myself.
1 out of 6.
Yes, that's very correct. Okay.
I am in medical school.
Oh, what you are? What? Good. All right. Probability of getting 1 is 1 out of 6. What's the odd of getting 1? Do you know? Anyone know? That's a very, very hard
It's not
question.
1/6.
No, it is not 1/6. Odd and probability is a different. Okay, listen very, very carefully. Odd is probability of getting outcome, getting 1, over probability of not getting 1. Okay, so what is this thing? Probability getting 1 is a 1 out of 1, 2, 3, 4, 5, 6, right? Probability of getting 1, right? That's this one. Probability of not getting 1 is the probability of getting 1, 2, so 2, 3, 4, 5, 6, not 1, out of 1, 2, 3, 4, 5, 6, right? So this is what? 1 out of 6, right? This
So
is what?
1/6 over 5/6.
Yes, 1/6 over 5, 6, right? So 1 out of 5. So odd of getting 1 is 1 out of 5, right? So that's very surprising. 1 out of 5, what the heck? That's how you calculate it. 1, 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, out of 1, 2, 3, 4, 5, 6. Okay.
So it's really the odds of not getting 6. I see.
Yeah, not
You have
getting
to
1.
calculate. Yeah, I see. Yeah.
Yes.
Because it has 6 sides, so it's not only the odds of that one. Wait, it has a die has 6 sides.
Yes.
Yeah. So
Getting
right, it's
over
not only
not
the
getting.
odds of that one side coming up; it's the odds of the other 5 not coming up. I got it.
Yes. Okay. So understanding odd ratio is very, very important. Okay. So so in this again, I just keep repeating by myself. Case control only case control odd ratio. All other measures are not meaningless. You can calculate it, so that has no meaning to it. Okay. So odd ratio is calculated because I just say it's 1 out of 6, 1 of 5 instead of 1 of 6, right? So odd ratio is, this was A, B, C, D, is calculated as A over C over B over D. Okay? Odd ratio is this. If you write in full term, A over A plus C over C over A plus C over B over B plus D over D over B plus D. Okay. If we simplify, it will come out to B over D. Simplify, it will come out A over C. Okay. So, this is kind of, this is how supposed to be, but you simplify it, you come up with this way. Okay. So this was like a probability of getting A out of A plus C, all possible outcomes. The probability of getting C, probability of getting the all the outcomes. Okay. So probability of, which is a probability of getting A, probability of not getting A, probability of getting B, probability of not getting B. Okay. So that's how the odd ratio works, and then and it says that shortcut here, right? Shortcut here, right? High yield, right? What I would do is remove this line and then even high yield. Just don't even look at it. That is because what happened is the reason that I try to do that is if you A, B, it'll turn out to be the A of C and D of B of D, and then the C, D over the A, so what is it? B over D, sorry. The AD over B and C, right? If you try to memorize this, that's the simpler, right? B, C, right? It's simpler, but you will not interpret this the formula because it is a simplified form. Is this? But does it have any meaning? No meaning. It's just a calculation, convenience of calculation. So just get rid of this line completely. Even if they say high yield, don't matter. Just completely get rid of it. If you see the first state here, there's a odd ratio right there. You see, I got rid of it. I just removed it. Okay. If you in your first state, remove it. All right. Okay. So the more important thing is in here right there. Odd ratio is 1. It simply means that chance that you get the exposure. So basically, yeah, another thing is important. Yeah, this is an important thing. Yes. So in odd ratio, we in the relative what happened here? In relative risk, we measure because we are dividing these two people, exposure group, non-exposure group, right? We are trying to measure the whether it will develop the lung cancer, right? Now we are doing opposite. We are not doing that. We are recruiting the people based on the lung cancer or no lung cancer. Lung cancer, no lung cancer, right? So we are looking at the backward. Did you have a lung cancer? Yeah, okay. Now, did you smoke in 10 years ago? Did you not smoke? Okay. If you don't have lung cancer now, okay. Did you smoke 10 years ago? Or did you not smoke? Okay, so we are now looking at this way, not this way. Okay, so the question will be different. In the relative risk question, we have you have the exposure that will increase the risk, or exposure not increase the risk, right? Now we are looking at the different thing. Because we have an outcome already. Now we are looking backward, asking questions in the backward, in the back years, so 10 years ago. Did you smoke? You have a lung cancer? Okay. Did you smoke 10 years ago? No lung cancer? Okay. Did you smoke 10 years ago? Or did you not smoke? Okay, that's the question. Okay. So the interpretation is different. Odds of exposure 10 years ago increased if the lung cancer patient. Odds of smoking is high If the odds ratio is high, means, so for instance, the question it will be like this, and then this is the you will see the like vignette that, and the researchers are studying the lung cancer, I mean the smoking exposure of 10 years ago, and then they found out like 10 like 100 people in the from the hospital chart, and then they compared to another 100 people, and then they ask people, each people, lung cancer people and the non-lung cancer people, 10 years ago, did you smoke or did you not smoke? Okay, that's what they asking. So the conclusion is that an odds ratio is come out to be like the like 3 or something like that. It's greater than 1. What does that mean? And then this will be answer choices, your answer choices. Odds of smoking increased if the lung cancer occurs. If the lung cancer occurred, then the odds of the smoking is high. Okay, that's the exactly come out in your answer choices of the questions. Okay, the question will be this one. They will also the I'm sure that they will ask this kind of questions. Answer one of the answer choices will be like this. Smoking increase the lung cancer outcome. That's one of the answer choices. If they describe the question like this, and then as I said, like the lung cancer patient and the non-lung cancer patients was selected, and then the like they look at the questions, the patient chat 10 years ago, and then there were some people who smoke and then non-smoke, and then the odds ratio was turns out to be like a greater than 1, like a 3 or 5, right? Then what does that meaning? What does that represent? And then the answer choice will be other of smoking increases if the lung cancer is occurred. And then that's A. And B will be the smoking will cause the lung cancer. Okay? This is not going to be the answer. That's what I'm saying. A will be the answer. Okay? This is a very, I mean, looks same to me, right? At first, the looks same to me. Smoking caused smoking exposure caused the cancer. Yeah, what's wrong with it? That's a totally different thing, because we are now looking at we know the lung cancer and then no lung cancer people. We don't know. What we are trying to find out is whether they smoked in 10 years ago or not smoked 10 years ago. That's what we are trying to find out. So that's two very, very different things. So understand this. And then because of this, the case control study, and then you find out odds ratio, and then this happens. Very, very important, okay? Likewise, in the relative risk, they will ask this question. The exposures, this relative risk comes out to be like 6, greater than 1, right? So what does that mean? Does it mean that smoking increase the lung cancer? I mean, like if it's a 6, what that means is that the smoking will increase the chance of getting lung cancer by 6 times. Okay, that's what the interpretation for relative risk. Okay, so if they say smoking exposure will increase the risk of lung cancer by 6 times, that's the correct answer. But they will one of the answer choice will be lung cancer patient to have a the 6 times higher chance of getting smoking. Looks same to me, right? But they are totally different thing, because you are looking at we are now looking at this way, right? But your thinking is now looking at this. That's a different thing. Cause and effect are different. Cause and effect has to be in terms of time. Okay? Very, very important to distinguish between these two. So that's why I keep asking about the interpretation. Interpretation is very, very, very important. That's the basically key. if you don't know the interpretation, you will get the question right, because you will not get the question right, and then you will eventually not only it's not only one question, but problem is it's not only the question. That's you just don't understand what's the meaning of the study, what's the meaning of this case control versus cohort. That's very, very important. Okay. All right. There are other things, they specifically mentioned with the relative risk, because what happens is with the odd ratio, there's like really, if they say here with odd ratio, right, then you can still calculate because it's a 2 by table, but that's basically meaningless. They don't ask that kind of thing. Okay. So with the relative risk, you can calculate all these things. Relative risk reduction. Now this part you can you can just like just memorize the formula. Some memorize the formula, but some of them they still ask some questions, interpretation. But interpretation most of the time this will be in the exam. This will be in the exam, guarantee. If they ask even Dr. Akuna or the some other even Dr. Akuna, okay, even Dr. Akuna, if he doesn't ask these questions, exactly the same thing. If this doesn't come into your cast, the serious problem. It's not going to happen. Okay? He will definitely ask questions. That's a key point. All right. So this one may or may not appear, but relative risk and then odds ratio, that has to appear. Okay. And then relative risk reduction is like if you have two choices. If you have one experiment with the smoking, no smoking, and then do some lung cancer, no lung cancer, to the one the question, one like a study, and then another like maybe study, not the smoking, something else like maybe the redhead, no redhead, that kind of things, right? Then maybe alcohol, say alcohol, no alcohol, and that kind of thing. What's the like the beneficial or the like more like maybe more the harmful effect. Okay, so that kind of thing is the relative risk reduction, which is calculated as like the 1 minus RR. Okay, relative risk. Okay, and then absolute risk reduction. Okay, absolute risk reduction is actually there's a one term which will be very, very, very confusing term. And I don't like this term, but that's what they use. Absolute risk, not absolute risk reduction. Okay, absolute risk is another name for incident. Incident. It's a very, very confusing. I think this has to be this term has to be changed. But they still use it, absolute risk. But absolute risk means incident. Okay. So absolute risk reduction has nothing to do with this is totally different thing. Okay, absolute risk reduction is very different from absolute risk. Absolute risk is instant. Okay, so this is kind of very, very confusing term. I don't know why they use absolute risk as an instance, but it means instant. Okay, don't get confused with the like the absolute risk reduction. This has a no relationship at all. Okay, same thing for cohort. Cohort in English term, it's basically group of people that has nothing, no relationship with the cohort study. Okay, don't get confused. Luckily they don't use this term very often. So, but just to let you know. But what's his name? That the book that this book, yeah, this book, the Fletcher book, they use this term sometimes. So so you gotta be careful about this thing. Okay. All right. So absolute risk reduction is minus. And then relative risk reduction is basically division. Okay. Relative risk is also division. Okay. So attributable risk is also minus, but this one is like the risk exposure minus unexposures. Okay, so what's the attributable risk? Just digest the word. So attributable, isn't attributable some kind of term, kind of blaming something? I attribute I failed the exam because of you. I he got the lung cancer because of something, right? So attribute risk. I attribute that my failure or my success uh, due to you, due to some kind of factor. So that's what that means. Okay, attributable risk is like the risk of exposed minus risk of unexposed. So risk of exposed is like this A, B, C, D. So, true positive, the false positive, false negative, false positive, right? I mean, true positive, true negative, right? So A of A plus B. This was like a term that risk, this is a risk for exposed. And then this is a risk for non-exposed. Minus, that's the risk of the attributable risk. So the question will come out in the like uh, this format. What's the risk minus risk? What's the difference between the risk exposed of risk of non-exposed? So that's how they the word this question. Okay. So another important thing will this number needed to treat. Number needed to treat is simply one of ARR. ARR is absolute risk reduction. So which was like unexposed to exposed. It's opposite. So, you will get very, very confused. Oh my God, which one minus which one? So the way you remember is attributable. You attribute, you kind of blame something. So exposed minus unexposed. And then absolute risk reduction is just you are so this has to be larger than this one. Okay. So in the medical biostatistics, right? Biostatistics, they rarely use minus terms, minus numbers. Most of the time they use like just a positive terms. So in other words, you can just freely say this one, something reduction, then you can freely say big minus small. 99.99%, this will work. Very, very few times. The only question which you really have to what's exposed and what's unexposed, what is smoking, what is non-smoking, you will have to consider this. Was there's only one example, one question that appeared in Fletcher book. If you do the Fletcher book practice questions, only one question. Okay, so 99%, 99, 10% times you are free like to say, oh yeah, big minus small. Okay, it will work most of the time. Okay, but if you find out there's only one example that I had to like the subject from like the unexposed to exposed or exposed to unexposed. Okay, so that's the only one question. So for now probably you are okay with the big minus small. Okay. All right, and then the number needed to treat is like 1 minus AR, and the number needs to harm is also the like 1 minus AR. Okay. Now, one little thing is that number needed to number needed to add. This is, I think, I think this one has to be, if it's say this was, yeah, this one is like 5.3. If it come out to be 5.3 and then 6. Okay, let me just write down here. 5.3 will be 6. If in number needed to harm is like the down, so like 5.3, it will be 5. Okay. So this is just basically by convention, not very, very important. And they usually don't make the questions like so the kind of so mean that the 5 point like 6 point, I mean 6 or 5 or 6 and the same the questions. They usually don't do that. Okay. All right. And then sensitivity and specificity. Okay, I basically, we are kind of out of time. So I'll just go over a few important points here. But if you have this, actually biostatistics is one of my kind of, very comfortable area. So even after this session, and if you have a problem and while you're taking the courses, then just you can just book me anytime, and then I will, I'm gonna offer the more biostat the sessions in the during the tutoring. I mean during the TA sessions. So last semester I for Med 2, I did like I spent like sometimes I had like 3 or 4 sessions in the week for biostatistics. So because not many people, not many TAs volunteer for biostatistics, but they are not very comfortable with. So I'm comfortable with the biostatistics. So you are more than free to welcome to like ask me questions after these sessions. Okay. Anyway,
Thanks. Thank you.
no problem, no problem. So sensitivity and specificity. Sensitivity means that the okay, if the test is like very sensitive, what that mean? What does it means that, for instance, like the good example is let me see what's a good example. Good example is okay. So say think about the cervical cancer. You do the like the Pap smear. Pap smear is a very sensitive test. Okay, so you detect the Pap smear positive means, oh, it's a very likely. I mean, it's a basically Pap smear positive. Then you do the second test, more diagnostic test. Okay, which is a colpography or colposcopy, or some like the biopsy and the kind of things. Okay, so colposcopy means that it's like a very specific test. So what happens is that here, what you're trying to do in the sensitive test is trying to rule out. What do you mean by rule out? So if you are negative, right? Negative result, test negative, then you don't have it. Test rule out. I think it's better to take this screenshot because this will disappear. This sensitive test means rule out, to rule out. So if you are testing negative, then you don't have disease. Okay? Whereas specific test is if you test positive, then you rule in. Meaning that if the test is, if you do this specific test, and then it turns out to be positive, then you have it. Then you have the disease. See the difference? It's a sensitive test is like a initial test, usually initial test, and this is a confirmatory test. Okay, so you do this sensitive test, and then you good example is like a pap smear. I mean, there are many opportunities, many initial tests, right? Initial test, and then you do this test. If you are not looking at positive, you are looking at the negative. If it's a negative, the test is negative, then you are okay. You don't have to come back. You don't have disease. Don't worry. Basically, don't worry. If negative, don't worry. Here, census specific test. If it's a negative, I mean, if it's a positive, then I'm sorry, you have disease. Okay. That's the, yeah. Now you can take screenshot in here. It's really messy, but sorry about that. Okay. All right. So that's the sensitivity and the specificity. Sensitivity is like the A, B, C, D. Your sensitivity is this way. Specificity is this way. And then here. What that means is that A over A plus C is a sensitivity, and then specificity is a C over B plus C. Okay, that's a specificity. That's how you calculate it. And if you really think about this, true positive, out of true positive, so all positive test, right? I mean, all positive, real, truly positive, right? Lung cancer patient. And then how many are really had exposure to the lung cancer? Okay. So that's what means. So, how many among lung cancer patients? So in other words, if you don't have if you the didn't smoke, right? Then you have a very little chance the lung cancer. If you didn't smoke, so I didn't smoke, then you don't have lung cancer. Okay, so that's how you if it's so in other words, if it's if what that means is that if it's a true positive, right? True positive over true positive plus the false negative, right? So what this is high means that in order to become this high, this false negative has to be small, right? So that's why the maximum number it can have is 1, right? It's close to the 1, that means the false negative is very small. So false negative means false negative small, very small. What does that mean? It's close to 0, because you cannot have negative number, of course, right? So it's close to 0. So that's what that means. False negative means 0, means that if it's a negative, then it's not you don't have disease. Okay, so highly sensitive the test. If it's a negative, don't worry. If it's highly specific test, if it's a positive, then I'm sorry. Okay, that's it. All right. So that's the sensitivity and the specificity, and then one last thing is a positive and the negative predictive value. What simply means that it's a if it turns out to be positive, how much do you think I really have the disease? For instance, if you chest X-ray shows that you seem to have I have a lung cancer. You seem to have a lung cancer. Then, doc, how much? What's the real probability? What's going to be the probability that I really have a lung cancer? What do what you said that I might have a lung cancer. What's the real probability that I have a lung cancer? That's the positive predictive value. If it's negative, then you tested your X-ray you don't seem to have the lung cancer. Do I have to believe you? Are you really trustworthy? That's the question. Are you really? Do I really not have the cancer? That's the question, okay? That's the negative predictive value, and then that's the positive predictive value. Again, you measure this true negative, true positive here, true negative here, okay? So what's really, if I get the positive test, what's really the probability that I really don't have the lung cancer? If the X-ray negative, then Are you sure that I don't have any other the lung cancer? That's the positive predictive and then negative predictive value. Okay. Okay, so I will stop here, and then there are a few more pages that more kind of the more kind of the explaining the statistic. Okay, and the make sure that you look at the beginning of the semester, you look at the syllabus, and you look at the schedule, and if it's a Dr. Akuna, yeah, I'm very, very sorry. But if it's Dr. Akuna, make sure that you get this book, PDF file from somewhere, and you need to, spend time from the beginning so you can read the contents instead of just, the only doing the practice question. But practice questions, minimum like twice is a kind of requirement. If you don't do the practice questions, you will really mess up with his questions. Okay. All right. So thank you very much. And then basically I will just stop recording here, and then we will do the on Monday we'll do the final